Alright, so here we are with the notes section of our, what is this, 2.7, okay? The idea, of course, is that we will be going through example 1 and kind of identifying the pieces, and then you will apply this knowledge as you work through part, 2 and 3. Alright, so taking a look, again, this is real-world applications of factoring. As you can see in this image here, we've got a diver. Apparently their name is Devani, and Devani is standing on the high dive platform. Very scary. Okay, the function that describes her dive, apparently there's a guy diving, but it says her. Anyway, is negative x squared plus 3x plus 10. So the way that this person is going into the water describes that pattern, where x is the time in seconds and y is the height in meters. So we need to use the concept we've learned to answer the following questions. So first thing is that we need to factor this. So as we look through this, the first thing that you would do is find a GCF. I can see that all of them, because I want a leading coefficient of 1, could potentially be divided by negative 1 to get me started. So negative 1 is actually out front, and we'd be left with x squared minus 3x minus 10. As we continue on, that's when we identify what multiplies to be negative 10, but at the same time would add to be negative 3. And so the factors of negative 10 are going to be negative 1 and 10, 1 and negative 10, negative 2 and 5, and 2 and negative 5. And we're trying to find which ones add to be negative 3. So that's going to be this set. If those are the two that add to be negative 3, that means that 2 and negative 5 are part of our answer. We have an x plus the 2, an x minus the 5, and then don't forget that technically out front is a negative 1 as well. So, as we look at this example, notice that they say y is the height, so we want to double check that we get that, and don't forget that it's in meters, and x is going to be your time in seconds. Alright, as we go through that, the zeros, remember, are the opposites of what we factored. So zeros are going to be opposite of positive 2, so negative 2, and then also opposite of negative 5, which is 5. So what do the zeros mean for this dive? That means technically, and this is why it's weird, if this is negative 2 seconds, if we actually pretended that this person started diving from the water and then somehow jumped up and came back down, which is completely impossible, okay, negative 2 seconds before they started would have been when they needed to launch themselves out of the water. Okay, so really when we talk about real-world applications, this one is not applicable. Okay, either way, what do the zeros mean? It means that at 5 seconds after the beginning of the dive, that is when Devani is going to land. So 5 seconds after she starts to dive, she reaches height 0, which is the water. So again, you can see how each of these is applied. So 5 seconds instead of just 5, and then 0 for your height, meaning at water's level. Alright, then we continue on, and they want you to identify the y-intercept. And so remember that in order to get the y-intercept, that means your x equals 0, and so we would just plug that into our equation. So officially, we'd have negative 0 squared plus 3 times 0 plus 10. So that first set is going to be 0. To that we'll add 0, and then finally add a 10. So our official y-intercept is at 10. So the y-intercept means that there are going to be 0 seconds, but then 10 meters. And so that just means that Devani starts at 10 meters of a diving board. So again, a 10-meter diving board above the water. Whoops. It means they're diving from the 10-meter platform. All right, next piece here, how long does Devani have to perform her dive, and what process did you use to determine that? So again, as this diver is going into the water, they've got from starting point here all the way up in the air and back down to perform their dive. So how long does it take to get from here to the water's edge? And that's where we talked about it's 5 seconds, right? So we talked about this would be time 0, and this would be time 5 seconds. Technically, this is time -2 down here. And so if you imagine it as a equation of a graph, we are looking at that as the actual dive, and then this as kind of the negative process. So officially from 0 to seconds of 5, they have 5 seconds to do the dive. And again, what process did we use to determine that? We talked about the time from the y-intercept, which is the start, to the 0, which is the water level. All right, then they want you to find the vertex, okay? And so as we look at this scene, our vertex is up here. So kind of that that highest point. And so that highest point we're going to find, we can do our strategy of the previous lesson, which is averaging the zeros. So if I take the 1, 0 of -2, 0, and the other one of 5, 0, I would take the x's, which is -2 and 5, and do their average. So our x value of the x-intercept is -2 plus 5 divided by 2. So apparently 3/2 or 1.5 seconds. The next piece is plugging in that 1.5 into the equation. So to get our y, we need to take -1.5, the quantity squared, plus 3 times 1.5 plus 10. If we break it down into pieces, -1.5 squared is -2.25. To that, we're going to add 3 times 1.5, which is 4.5, and then, of course, plus 10. So it turns out that our y value is 12.125. Sorry, it's 12.25. That's a weird 12.125. Okay, so according to the vertex, how high in the air does Devani reach? Well, it's at time 1.5 seconds, but it's actually 12.25 meters. All right, and so that process of each of these is what you're going to do and apply in our next 2 scenarios. Okay, so again, your assignment would be part 2 and 3 here, and it's going to be the same process as what we did here in the notes.